Let's talk about domain and range. Domain is a set of possible inputs, and range is all the possible outputs of a function. So let's say you had some function from ABC to 5, 7, 10, 11. I don't know why I'm always using ABC. You could just do ABE. Yeah. It doesn't have to be ABC. It could be any other thing. You could have numbers here. But anyways, let's say you have some set, another set, and you have some pairing. You pair A to 5, B to 11, and E to 7. Let's say you have some random function. And in this case, the domain is A, B, E. These are the possible inputs to this function f, right? If you plug in any other value other than A, B, and E into this f, it's not going to work. A and B and E are the only things allowed into this f. It's like in a factory, you have some gigantic machine, and there's a sign saying there, oh, the only things that you're allowed to plug into this function, this machine, are A, B, and E. Do not put anything else. That's the domain. And the range in this case are everything that's produced by the machine. It produces 5, 7, and 11, right? It does not produce 10, so 10 is not part of the range. It's 5, 7, and 11. Now, domain and range is quite important when you deal with functions, because you don't want to plug in illegal values. So in a function that we usually encounter in precalculus, functions in precalculus, we're usually presented with a formula for it, right? So f of x, if you have like 3 over x minus 1, then the domain of this function is you can put in anything, all reals, except 1, right? What happens if you try to plug in 1? Then you get a denominator as 0, and you're not supposed to divide by 0. It gives you undefined. So 3 over 0, that's what we call undefined. It's an undefined value. So all reals except x equal to 1 is your domain D. We also learned this interval notation. So let's try to rewrite the domain in interval notation. You need to know how to do this. So here's the number line 0, 1, 2, -1, and so on and so on. Now it's all reals. You can plug in any real number except this 1. So you put an empty circle there, and you can plug in anything after 1. You can plug in anything before 1. You're just not allowed to plug in 0. Plug in 1. If you have this 1 empty, that means the number line, the real number line, breaks into 2 intervals. One interval is from -infinity to 1. Another interval is from 1 through infinity. And when you have more than one interval, you put union u, and that's your domain. Okay, so the domain of this function is 3 over x minus 1. Now, what's the range of this function? Range, unfortunately, is not that easy to be figured out just from the formula. In most cases, domain you can just figure out from the formula. Range, you need the graph. And we haven't learned how to draw the graph of this, so let's just assume that you figured out the graph by some calculator, or you you are presented with a graph. So let's say you're given the function, formula, and the graph, and the graph was like this. Okay, so the graph of 3 over x minus 1 is something like this. There's a vertical asymptote at 1, so the graph gets closer and closer to 1, but it doesn't touch it. Same thing happens. There's a horizontal asymptote at 0, so the x-axis is like a horizontal asymptote. It gets closer and closer to 0, but never touches it. And in this case, since y is the output and y is the height of a point, right? So at any point, the left or right is controlled by the x value, up or down is controlled by the y value, right? So if the y value is up or down, and you can see that it can go up as much as you want, it can go down, well, kind of much as you want, but you can't get to 0. You can only get close to 0, but not actually equal to 0. Same thing over here. You can have negative y values, but you can never achieve 0 itself. Then from this graph, you can say that the range is like all reals except 0. So this time you have the two intervals like before, but it's broken at 0. Now, that immediately raises the question of how to find the domain. So there are some basic things that you have to know. So think about an example. Y equals to square root of x minus 5. So if you have this function, square root of x minus 5, what's the domain? Now you have to know that square root of 0 is 0, so that's okay, but square root of negative 1 is what we call the imaginary number, and this is not a real number. And in pre-calculus, we only work with functions that take in real numbers and outputs a real number. We never work with functions that outputs imaginary numbers. Okay, we may deal with imaginary numbers when we solve quadratic equations sometimes, but in pre-calculus, a priori, when we define functions, we just assume that it's a real function. It's a real valued function which takes in real value inputs. So that's our assumption when we work with pre-calculus. That same holds for calculus 1 and 2. In those classes, whenever a function is presented, we assume that it's a real function. Okay, so this immediately tells us that 4, for example, cannot be an input, because if you plug in x equal to 4, 4 minus 5 will be negative 1, and square root of negative 1 is not real. So what will be a condition whenever you see a square root? The condition is that x minus 5 are allowed to be 0, and it's allowed to be bigger than 0, but it's not allowed to be negative. So you have this condition, x minus 5 has to be 0 or bigger, and if you add 5 both sides, you get this, which means that the domain is 5 and afterwards. This time 5 is allowed, so you put a closed circle, and then this is your domain. Okay. You have only one domain with 5 included. Since 5 is included, you use a square bracket or the closed bracket, and it extends till infinity. So that's your domain. So here are the observations that we have made so far. So functions with fractions. denominator cannot be 0. Okay? And functions with square roots. Okay? The thing inside the square is called the radicand. That has to be 0 or greater. Okay. Now, one additional thing I should note is that if you take the cube root of -1, this is perfectly fine because it's -1. Because if you take -1 to the cube, it is -1. So if you take the cube root both sides, then this cancels and you get -1 equals the cube root of -1. So that's a perfectly fine answer. Therefore, for cube roots or any odd numbers like 5th roots, 7th root, any number can be plugged in. On the other hand, if you have a 4th root, 6th root, all the even numbers, in this case the radicand has to be non-negative. Okay, it has to be 0 or positive. Okay, so let's do 2 more examples and we should be able to understand what we're doing. So find the domain of first, number 1, f of x equals to x cubed over x squared minus 3x plus 2. Okay. In this case, it's a fraction, so we can't have this equal to 0. So let's see when this actually becomes 0. This can be factored as x minus 1, x minus 2. So you get x equal to 1 and 2. So you see that this is all reals except 1 and 2. In other words, here's 1 and here's 2. Here you should have open circles, and that breaks up the entire domain into 3 intervals. And the domain will be negative infinity up till 1, union, and then 1 up till 2, and then 2 to infinity. That's the domain. Here's the second question. Let's say you have f of x equals to square root of x minus 3 plus 5 over x minus 8. Well, for this one, x minus 3 has to be 0 or greater. So, because that's the radicand, that's inside the square root, and therefore x should be 3 or greater. And over here, x minus 8 cannot be 0. So if you add 8 both sides, you see that x cannot be 8. So putting these together, this is what you have. Here's 3. This one says everything after 3 is okay. This one says, however, if you have 8, that's not okay. So at 8, you have an open circle. So you have open circle at 8, and 3 and afterwards is okay. So the domain is the interval from 3 to 8. 3 is included, but 8 is not. Union, then 8 and infinity. See how I use the square brackets here because 3 is included? In other case, since the numbers are not included, you should put parentheses.